Today we will discuss center of any group is a subgroup of this group. Okay. So how to prove? First of all, what is center? Center of a group G denoted by ZG, that is set of all element A belongs to G such that Ax equal to XA for all X belongs to G. That is center of G, that is those of element of G which commute with every element of G. Okay. So now here applying two step of subgroup test. Okay, two step subgroup test. Okay, so first we show ZG, center of the G is non-empty. Okay, and secondly we show AB belongs to center of the G whenever A and B belongs to center of the G. Okay, and thirdly we show A inverse belongs to center of the G whenever A belongs to ZG. Okay, so then we conclude ZG is a subgroup of G. Okay, if three conditions are held. Okay, now first condition, since the identity element of G, okay, we know that Ex equal to Xe for all X belongs to G. Okay, so this implies identity element belongs to H. Sorry, here ZG. So this implies center of G is non-empty. Okay, so first condition is solved. Now second, let AB belongs to center of the G. Okay, by definition of center of G, Ax equal to XA and Bx equal to XB for all X belongs to G. Okay, so now ABX, that is equal to ABX, that is equal to AXB from here. Okay, so that is equal to AXB, and from here we have XAB. Okay, for all X belongs to G. So that is AB is commute with every element of G. So this implies AB also belongs to center of the G. Okay, now second condition also satisfied. Now third condition, inverse. Now for third, let A any element of center of the G. Okay, so this implies by definition of center of G, this implies Ax equal to XA for all X belongs to G. Okay, we want A inverse X equal to X A inverse for all x belongs to G. Okay. If this hold, then we implies A inverse belongs to ZG. Okay. So now from here Ax equal to XA for all x belongs to G. Okay. Now applying A inverse in both sides. Okay, so A inverse Ax and here also implies A inverse XA and this is A inverse. Okay, now A inverse A X A inverse. Okay, this implies this equal to A inverse X and that is A inverse. Okay, and this implies this is identity and this is XA inverse and this is also A inverse X and this is identity. This implies X A inverse equal to A inverse X for all x belongs to G. So that is A inverse belongs to center of the G for every A belongs to ZG. Okay, that is every element has an inverse. So third property also hold. We have center of the G is a subgroup of G. Okay, for any group G. Hence the proof.